Today we will see what is correlation. In today's business world, there are many business problems, many business activities that are involved with two or more activities. These activities are dependent on each other. These are called variables, and these variables are dependent on each other. And when we are able to identify the dependency, then we'll be able to solve or resolve many problems. For example, not only they are dependent on each other, they are moving in the same direction. They are moving in the same direction. For example, yes, when one variable is moving in the one direction or increasing, that another variable is also increasing. When one variable is decreasing, the another variable is also decreasing. Or some cases, the variables are moving in the opposite direction. When one variable is increasing, the another variable is decreasing. When one variable is decreasing, the other variable is increasing. So now we'll see some examples: family income and expenditure, demand and price, advertisement and sales. Okay, we can go on adding many examples like this. Just we'll stop with this, and now we'll see what is exactly correlation. Correlation is a statistical technique that measures the association between two or more variables. So correlation technique is used to find out the relationship between or association between two or more variables. Not only this statistical technique is used to find out the degree or the direction in which way it is moving. Okay, yes, so we'll be able to find out whether there is a correlation or not, and then we'll be able to find out where in which direction it is moving and what degree it is there, the correlation is there. Is whether it is positive correlation or negative correlation, and like that, whether they are moving together or whether they are not moving together, like that, and also we will be able to find out. Okay, thank you. Yes, now we will see what are the methods, and also what are the methods of finding out the correlation. There are mainly two methods. One is graphical method, the other one is algebraic method. Now today, under the algebraic method, we are going to see Carl Pearson's correlation method. Actually the first person to give mathematical formula for measuring the degree of relationship between the two variables is actually in the year 1890. 1890 was Carl Pearson, and as a result it was named after him as a Carl Pearson correlation method. This is otherwise called as product moment correlation, or otherwise it is called as simple correlation. This is a very popular method, and this is denoted by small r. This is denoted by small r. Now correlation, this Carl Pearson's correlation method is there are a direct method like that and all we are having. Now we are going to see the Carl Pearson method for the grouped data. Okay, yes. Now here in this problem, yes, the grouped data is given. Yes, on the column wise average salary is given, and the row wise the expenditure on entertainment is given. Now we'll see how to solve this problem. Okay, now x is given on the is column wise, and y is taken on the row wise. Okay, now x actually leaving in thousands, and we have just taken 0 to 10, 10 to 20, 20 to 30, 30 to 40, like that, and also 40 to 50. Yes, now is first step is that we need to find out the midpoint. Yes, it is nothing, midpoint is nothing but as usual is lower limit plus upper limit divided by 2. Yes, here this side for y 0 plus 10 divided by 2, that is 5. 10 plus 20 divided by 2, that is 15. 20 plus 30 divided by 2, that is 25. 30 plus 40 divided by 2, 35. 40 plus 50 divided by 2, that is 45. Now same way for x, 100 plus 150 divided by 2, 125. 150 plus 200 divided by 2, 175. 200 plus 250 divided by 2, it is 225. 250 plus 300 divided by 2, it is 275. 300 plus 350 divided by 2, 325. And then as usual, we will write what is given in the problem. Now next step is that also we have to find out f. We need to find out dy. Is that side dy, that is in the row wise we need to find out dy, and the column wise we need to find out dx. F dx we need to find out, f dx squared we need to find out, f dx dy we need to find out. F, how to find out? How to find out f? F is nothing but we'll add what is given. Row wise we'll add, okay, 5 plus 4 plus 5 plus 2 plus 4, it's 20. We'll put it as f this side. Yes, on the for 0 to 10, that is the f. And similarly, like for there is 2 plus 7 plus 3 plus 7 plus 1, that's 20. Yes, then 6 plus 4 plus 5, 15. Yes, 8 plus 4 plus 8, 20. 7 plus 3 plus 5 plus 10, that's 25. And similarly, f for the column wise, that is for x variables. 15 is 5 plus 2 plus 8, 15. Is 4 plus 7 plus 6 plus 7, it's 24. Like this we'll find out the f. Your f will be the same for the both the sides, x and as well as y. N, that is called as capital N. Okay, now next step is finding out the dx and dy. Now take the middle as the assumed mean. That's nothing but x minus x bar, x minus assumed mean and y minus assumed mean. That's dy and dx. Now how I have taken here 25 as the a for the x, y, x for x, and for y, and for x also I have taken 225 as the a. Yes, now also what I am just doing is that also it's how to do is the 25 5 minus 25 divided by class interval, that's minus 2. Okay, 15 minus 25 divided by class interval. Class interval is 10 here, so minus 1. 0, the same way 35 minus 25 divided by class interval 10, 1. 45 minus 35 divided by class interval, that is 2. Okay, the same way here also is 225. 125 minus 225 divided by 50, so that's minus 2. 175 minus 2, that is minus 2. So that is 175 minus 225 divided by 50, minus 1. That the next one will be 225 minus 225 divided by 50, that is 0. 275 minus 225 divided by 50, that's 1. And 325 minus 225 divided by 50, that's 2. Okay, now we have got how to get f dx or f dy. Multiply f dy column, that's all, very simple. Okay, then get the sigma f dx, sigma f dx and sigma f dy. Add that what you have just calculated. Okay, and here and so the next sigma f dx squared and f dy squared. Multiply the f dx with again with the dx column, okay, or dx row, and f dy with the dy again. Okay, Now again calculate sigma f dy squared. Then next one is that also, yes, we need to calculate f dx dy. F dx dy. How to calculate f dx? How to calculate f dx dy? How to calculate f dx dy? That is what is in the grades box, that is inside the cell. Grade box inside the cell. How to do it? Okay. Now what I am doing is that also, yes, what is that also, dy, actually dy we have got no ma. Yes, that dy is minus 2. Yes, and my dx is minus 2. Minus 2 into minus 2, that's 4. And now that what number is that frequency in the cell, I'll multiply, that's 520. I'll put it in the first grade box. Okay, and now and so again coming to the this dx, that's minus 1, and dy is minus 2. That multiplies minus, I'm just getting 2, multiply it by 4, I'll put it as 8. The next one is that also, what is it, 0, so that will be 0 only. Yes, and then 1 into minus 2, that is minus 2. Minus 2 into 2, it is minus 4, so it will be, that will be minus 4. The next one is that also, my 2 into minus 2, that's minus 4. Minus 4 into minus 4, it will be 16. Okay, minus 16. Okay, now what I'll do, this way you have to calculate for the other rows also. Okay, now what is that is, and so you have to add what is in the grade box. That will be your f dx, and so f dx dy, f dx dy. Okay, that is 20 plus 8 plus 0 minus 4 minus 16, that is 8. Similarly, you have to calculate also for all this, and also calculate for this side also and that side also. Your sigma f dx dy this side and your sigma f dx dy this side will be equal. See, 46 this side and 46 this side. This way you will calculate. Okay. Yes. Now here, yes, as I said, your midpoint, that is 225, that I have taken as dx and dy. Now your formula for this is, yes, r is equal to, yes, n sigma f dx dy minus sigma f dx into sigma f dy divided by root of n sigma f dx squared minus sigma f dx squared into n sigma f dy squared minus sigma f dy the whole square. Then substitute what you have got. Okay, what we have calculated. Now you will just get 0.2052. That is what also. Yes, it is plus 0.2052. Now this is actually very low. Actually it is positive correlation. The correlation is positive correlation, but it is low degree of positive correlation. Low degree of positive correlation. R is equal to 0.2052. That is positive correlation, but it is low degree of positive correlation. So the average salary and the expenditure on entertainment and also is very low, but it is positive, but it's very low. But it has only low influence over the entertainment expenditure. The salary has only low influence over the entertainment expenditure. Like this you have to write the conclusion or interpretation. Then only you will get the full marks. I hope you are clear with the calculation of correlation for the grouped data. Be thorough with the formula and you must write the interpretation also. Then only you will get the full marks. Just also, if you are just calculation, if you are doing the calculation and if you are with the calculation, if you are leaving, you will not get the full marks. Okay, thank you. I have sent the homework and also for practice to your mobile. Thank you.